Okay, so welcome to, I think, what is the 2019 DB mock exam. Right, the figure shows the logo for an amateur theatre logo based on ellipses, parabolas, tangents, so on and so forth. Okay, so the curve ABC is an ellipse with a major axis of 120. Right, so the major axis, so no minor diameter, no focal points. So what do I have, right? Okay, so I have point P in the curve. It's over 45 and it's up 20. So if I have a point P in the curve, what I can do is I can go back from point P to until I hit my major circle. So I'll draw in my major circle there. And I can go back from point P until I hit my major circle. Now when I hit my major circle, I can go back to the center of what you call it, the ellipse, and I can go parallel to my major axis here until I hit that slope line. There's a point on the minor circle. I can draw in my minor circle then. And then I can divide my major and minor circle up into 60, 30, and as you've seen before, the sketch done the question, it's a good idea maybe to sketch all the question out in the question sheet. It takes max 5 minutes and save you a lot of time. So then where the division lines hit the major circle parallel to the minor axis, where they hit the minor circle, the small one, parallel to the major axis, and where they intersect are points on the ellipse. So we'll begin. So the major radius is 60. Point P is 45 from the center and up 20 is point P. Now, as said, from where P touches the major, where from point P we're going to go parallel to the minor axis. We touch the major circle. And we're going to join back to the center point. And we're going to go parallel to the major axis from point P until it intersects here. So 1, 2, 3, and then we get a point on the minor circle. And then we can divide this into 60, 30. And then we're going to go parallel to the minor axis towards the major from where the division lines hit the major circle. And then where the division lines hit the minor circle, we're going to go parallel to the major, away from the minor axis, so outwards. So here are the points on the ellipse. Now I'm going to freehand sketch them in, which is what I'm going to do now. Now, so I have the ellipse drawn there. The next part, it says EFG is a parabola. E is over 12, so is G. Point F is down 50 from the, bottom of the minor circle. So this is what it fits in. They give you 1, 2, 3, 4, 5 equal divisions here. So that's how much you're going to divide it in. It makes the most sense. So it does, and then this has to be divided into 5. So to do that, I'm going to draw a line at any acute angle. And I'm going to mark 5 equal measurements along that. So 1, 2, 3, 4, 5. I'm going to join the last point to E and all the points after parallel to them. And then I'm going to do the same here. I'm going to draw a line parallel to draw a line at any acute angle, and I'm going to mark 5 equal divisions along it. So 1, 2, 3, 4, 5. So I'm going to join the last point to F. All the subsequent lines are parallel to it. And then the blue ones go to F. And then these ones parallel to the axis of the parabola. Now where one touches one, so I'll label these 1, 2, 3, 4, 5, 2, 3, 4, 5. So where 2 touches 2, 1 touches 1, 3 touches 3, 4 touches 4, 5 touches 5 are points in the parabola. And then you can mirror them across by just drawing your lines across, taking your compass and flipping the points around for the other side. So we'll do that. Down 50. What's that? 9. Mark 12 to the left and right from the vertices of the parabola, which are called D and B. Now, as said, we're going to draw a line at any acute angle, and we're going to mark 5 equal divisions along it. So I'm going to mark this 10 centimeters long, mark every 2 along it. Now, I'm going to join the ends here. I'm going to draw the lines parallel to the one just drawn there. And then I'm going to join these points to F. Now, I have to do the division down below. So I'm going to draw a line at any acute angle down here, and I'm going to mark 5 equal divisions on it. So 5 equal divisions, and then I'm going to join the last 2 points to each other. And draw lines parallel to them. So 1, 2, 3, 4. 1, 2, 3, 4. So where 1 touches 1, 2 touches 2, 3 touches 3, and 4 touches 4. Right. And then we can mirror it over. So you can take my compass. So I'm mirroring the points over. And you can freehand sketch those points in, keeping the hand inside the curve, even though mine is outside at the moment. I'm going to pause and do that. So there's the parabola drawn in. How do you, then complete them out? Right. So the lines EI and GH are tangents from the ellipse, from the points E and G respectively. Alright? So these are tangent to ellipse from a point outside the curve. Now, to do this, you need the focal points. So how do you find the focal points? You take half the major, swing from the top of the minor. So I'm going to take half the major and swing from the top of the minor. And then I'm going to get F1 and F2. I'm going to draw a circle with the radius E to F1, the centre of E. So I'm going to draw a circle there. E to F1. Now this is to find the tangent. Sorry there, one sec. Now, the next thing I'm going to do is take the length of the major axis and swing from the opposite focal. And then where the arcs cross, we're going to join these to the furthest focal away. Furthest focal away. And that's the point of contact. Now, there's the tangent. Okay, so we can draw in the tangent, and we're going to draw it in lightly. So we're going to draw that tangent in lightly. To do the other side, you can simply bring the point of contact straight across because it's symmetrical, and just join through G. But make sure you show that line. Right, so we begin. We take half the major, swing from the top of the minor. So there's F1 and there's F2. Now we put our compass on E and we bring the nib to F1. We're going to draw in the circle. Now we're going to take the length of the ellipse and swing from the furthest focal. I'm going to swing an arc. Now where the crisscrosses intersect, we're going to join that to the furthest focal point. Now, here's the point of contact for the tangent. That's the point of contact. Now we're going to draw in our tangent lightly. Okay, lightly. And to get the other side there, I'm going to bring the point of contact across and do the same thing from G. One sec there. So I corrected those little accuracy errors there. Now, this is the tangent here set. Okay, we don't know where the tangent stops being heavy in terms in. We don't know this center point here. It's not in line with the bottom of the ellipse. Now it's a radius 17. Okay, so we're going to draw a line perpendicular to the tangent, and we're going to mark our 17 along it, and we're going to draw a line parallel to the tangent, and where it intersects the center line, okay, so 17 is really there, where it intersects the center line, the minor axis, is the center point of, the arc. And then to find the exact point it stops, if we go perpendicular to the tangent from the center, that finds the exact point of contact, as that's a normal. So that's a normal. Right. So I'm going to do that. So I'm going to take the set square, and from the tangent I'm going to draw a line anywhere along it, perpendicular to it. So I'm going to mark 17 along that, and then I'm going to draw a line parallel to the tangent where it intersects the center line. I'm then going to draw a line perpendicular to the tangent from there, and that's the point of contact there. Right? I can bring that then across just from my other one. This. Okay, so there's the tangent then. There's both tangents there. This. Okay, and then you can draw in your radius 17. Okay, I'll fix that in a moment. Right. You can also draw the teeth on the mouth. I'll fix that now 1 sec there. That has to be better. So fix that. Right, so we've that done. Now next part. The circles are tangential to the ellipse at points P and Q. So points P and Q. Now P we have. Okay, Q might be a whole different challenge, so it might. Now, to do that, alright, essentially the center point and the point of contact lie along the normal to the ellipse. So I'm going to go back a step here, possibly. Okay, so too much there. Right. So what do I need? I need my focal points to do this. So I need my focal points to do this. So half the major. You've already got the focal points. So this is a tangent to a point on the curve. So I'm going to join F1 to P, P to F2. We're going to bisect the angle with our compass. So you can set your compass to any length, swing an arc, okay, and an arc on this line. I'll do it properly. So you swing an arc here, both sides. Don't change the radius. Swing an arc from those intersections, and then this is the normal here. So that's diameter 30. So this is 15 here. You go back 15 from the point of contact, and there's the circle. Okay, now I'll do that one. And I'll look at Q. Maybe Q is symmetrical. I suppose it'd be safe to assume they are. Otherwise, you'd have a fairly out of place set of eyes. Right. So we have already got point F, F1 and P and F2. So I'm going to join F1 to P. So join F1 to P and P to F2. So P to F2. Now we're going to bisect that angle F1 to P and P to F2. So we're going to bisect that angle. So take my compass, set it at any length, swing an arc there and there. Lift your compass, don't change your radius, and swing 2 new arcs. And then when the arcs intersect, you join back to point P. Now, this is called the normal. That's the normal. Okay, and then there would be a tangent touches at one point only, so it'll only touch at that point. The diameter is 30, so you can measure back 15 along that line. And here's the center point for the eye. So here's the center point. So there's the center point for the eye. And then I suppose to be Q then will be directly across. So we can bring the point of contact across. We can do the same if we wish, or if we're tight for time we can mirror it through. Sometimes your sketches of ellipse wouldn't be the most accurate. So I join Q to F1 and F2. I'm going to set my compass to any radius. Swing an arc onto both arms. Don't change the radius. Where they intersect, join to point Q and measure up 15, the radius of the eyes. You can draw it in then. So there's the eyes. I'll heavy them in shortly. And then the last thing to do is draw in the face, which is down 8 from the center of the ellipse, and the diameter is 170, so that's radius 85. So down 8 mil, Physics 85. So there's the face drawn in, so I'll pause that and heavy all that. There we go. Cheers. Thank you. Bye bye.